Hi! So today, we will be discussing about the binary arithmetic operations. Under the binary arithmetic operations include the binary addition, binary subtraction, binary multiplication, and binary division. So let's proceed in discussing the different binary arithmetic operations. Binary addition. In binary addition, the rules are 0 plus 0 equals 0, 0 plus 1 equals 1, 1 plus 0 equals 1, and 1 plus 1 equals 10. In this example, you have to add 1001, 1001 to 101, 0111. 1 plus 1 is 10, carry 1. 1 plus 0 plus 1 is 10, carry 1. 1 plus 0 plus 1 is 10, carry 1. 1 plus 1 plus 0 is 10, carry 1. So here we have 3 ones. So step-by-step process, 1 plus 1 is 10 plus 1, and that will be 11, carry 1. 1 plus 0 plus 0 equals 1. 0 plus 1 equals 1, and bring down 1. So the final answer will become 11110000. Here is another example, but with decimal places. You have to add 1011.101 to 111.01. It's also the same with the first example, but here, you have to align the decimal points. So bring down 1, then 0 plus 1 equals 1, 1 plus 0 equals 1, then put the decimal point, and then 1 plus 1 equals 10, carry 1. So 1 plus 1 plus 1 equals 11, carry 1. 1 plus 0 plus 1 will become 10, carry 1. And then 1 plus 1 equals to 10. So the final answer will become 10010.111. Binary subtraction. In binary subtraction, the rules are 0 minus 0 equals 0, 1 minus 0 equals 1, 1 minus 1 equals 0, and 0 minus 1 equals 1, and borrow 1, or simply 2. In this example, you have to subtract 100101 from 10101110. First, since there is 1 beside 0, you have to cancel them out both, and then turn 1 into 0, and then 0 will become 2. So 2 minus 1 will become 1, and then 0 minus 0 will become 0. 1 minus 1 is 0, 1 minus 0 is 1, 0 minus 0 is 0, 1 minus 1 equals 0, and bring down 0 and 1. So the final answer will become 10001001. Here is another example, but with decimal points. In here, you have to subtract 100.101 from 1001.11. It's also similar to the first example, but here you have to align the decimal points. First, since 1 is beside 0, so we have to cancel them out both, and then 1 will become 0, and 0 will become 2. So 2 minus 1 is 1, 0 minus 0 equals 0. 1 minus 1 equals 0, then put the decimal point. 1 minus 0 equals 1. 0 minus 0 equals 0. Again, 1 is beside 0, cancel them out both, and then 1 will become 0 and 0 will become 2. So 2 minus 1 is 1. And the final answer will become 101.001.
Binary multiplication. Here we have some rules to follow in doing the binary multiplication. The first one is 0 times 0 is equals to 0. Next, 1 times 0 is equals to 0. 0 times 1 is equals to 0. 1 times 1 is equals to 1. There will be no carry or borrow that will happen in this rule. Lastly, multiplication follows the general principal shift, then binary addition. Here we have an example of a binary multiplication. 10101 times 110 is equals to blank. First step here is to multiply 10101 into 110. So we follow the rule. So 1 times 0 is equals to 0. 0 times 0 is equals to 0. Then 1 times 0 is equals to 0. 0 times 0 is equals to 0. 1 times 0 is equals to 0. So the technique here is that if you multiply 0 to any number, the answer will be still 0. Next, we multiply the second number. So 1 times 1 is equals to 1. 1 times 0 is equals to 0. 1 times 1 is equals to 1. 1 times 0 is equals to 0. Then 1 times 1 is equals to 1. Then we follow the pattern. So we multiply the third number. So 1 times 1 is equals to 1. 1 times 0 is equals to 0. 1 times 1 is equals to 1. 1 times 0 is equals to 0. Then 1 times 1 is equals to 1. Next, after we multiply all the digits, we will now apply the binary addition to get the answer. So here is 0, so just bring down 0, then 0 plus 1 is equals to 1. 0 plus 0 is equals to 0, then 0 plus 1 is equals to 1. Next, 0 plus 1 is equals to 1. 1 plus 0 is equals to 1. 0 plus 0 is equals to 0, then 0 plus 1 is equals to 1. 1 plus 0 is equals to 1, then bring down the 1. So the answer for this equation is 1111110. So 10101 times 110 is equals to 1111110. Here we have an example of a binary multiplication with decimal. So here we will be multiplying 1011.01 times 110.1. So to easily get the answer, the shortcut here is that if you multiply the one digit to the multiplicand, you just need to copy the whole value of it. So it will be 101101. Then the second digit will be 0. So the shortcut here is that if it is 0, if you multiply it to the whole multiplicand, the answer will always be 0. So the second answer is 0. So we have another one digit, so we will just apply the first shortcut, wherein we will just multiply the one digit to the multiplicand to get the whole value. So it will still be 101101. The fourth digit is still one digit, so we just need to copy the whole value again. Then we will apply the binary addition. So in applying the binary addition, we'll be adding this whole four products. So we will bring down 1, then 0 plus 0 is equals to 0, then 1 plus 1 is equals to 0. We will be carrying 1 for the other number. So 1 plus 1 is equals to 0, then 0 plus 0 is equals to 0, then 0 plus 1 is equals to 1. Then 0 plus 1 is equals to 1, then 1 plus 1 is equals to 0, then 0 plus 0 is equals to 0. Next, 1 plus 1 is equals to 0, then we will be carrying 1 for the next number, then 0 plus 1 is equals to 0. Next, 1 plus 1 is equals to 0, then 0 plus 0 is equals to 0. Then, 1 plus 1 is equals to 0. Then we will just carry down the other one. So the answer for this equation is 1001001.001. Binary division. We have some rules to follow in doing the binary division. 1 divided by 1 is equals to 1. 1 divided by 0 is equals to a meaningless number. 0 divided by 1 is equals to 0. Then 0 divided by 0 is equals to a meaningless number. Next, it is comprised of two binary arithmetic operation, which is the multiplication and subtraction. So here we have an example of a binary division. We will be dividing 101, 101 into 101. So here we will just follow the same division pattern for this binary division. So 101 divided by 101 is equals to 1. So we will be having the answer of 1. Then 101 minus 101, the answer will be 0. Then we will be bringing down 1. So the answer will be 01. And since we can divide 01 into 101, well, we'll be adding 0 to the answer. Then we bring down the next 0. Then since we can divide 10 into 101, we will be adding another 0 to the answer. Then we will bring down the other 1. Then since we can divide 101 into 101, the answer will be 1. So 101 minus 101 is equals to 0. So the answer for this equation will be 1001. Here we have another example of a binary division with decimal. So we will be dividing 1011.01 divided by 11. We will still perform the same division process for this equation. So 101 can be divided into 11, so we will have the answer of 1. Then perform the binary subtraction, wherein 101 minus 11. So 1 minus 1 is equals to 0, then 0 minus 1 is equals to 1. By borrowing the next one digit, so we will have 1 0 as the product. Then bring down 1, we'll be having the product of 101. And since 101 can be divided by 11, we'll be adding another 1 for our answer. Then 101 minus 11 is equals to 1 minus 1 equals to 0. Then 0 minus 1 equals to 1, while borrowing again the next one digit on its nearest place. So then we will bring down another 0, wherein our product will be now 100. And since 100 can be divided into 11, we will add another 1 to our answer. Then we'll perform the same process wherein we will be doing the binary subtraction. So it will be 100 minus 11. So 0 minus 1 is equals to 1, while borrowing the 1 to its nearest place. So 0 minus 1 is equals to 0. Then since we already borrowed on the nearest place of 1, it will only be, the product will only be 0, 1. So next we will be bringing down the last digit, which is 1. So our product will be 0, 11. So since we can divide 11 into 11, we'll be adding another 1 for our answer. Then we'll perform the same process of binary subtraction. So it will be 11 minus 11. So 1 minus 1 is equals to 0, and the other one is 1 minus 1 is equals to 0, for a total of the product will be 0. So we will have a remainder of 0 for this equation. So the answer for this equation will be 11.11.